We're going to use the distributive property. X times x is x squared. X times negative 5 is negative 5x. 5 times x is positive 5x. And lastly, 5 times negative 5 is negative 25. Alright, when we combine our like terms here, negative 5x and positive 5x is 0. So we're left with x squared minus 25. Now let's take a look at 5x plus 3 times 5x minus 3. 5x times 5x is 25x squared. 5x times negative 3 is negative 15x. 3 times 5x is positive 15x. And then 3 times negative 3 is negative 9. When we combine our like terms here, they cancel out. We're left with 25x squared minus 9. Describe any pattern you notice. When there is a difference of squares, what does that mean? That means that one of them is positive, one of them is negative. The expression is identical with the exception of one having a plus sign between the two terms and the other having the minus sign. When that's the case, the middle term cancels out. So what do you notice? The middle term cancels. As we take a look here, remembering that, again, we have identical for the binomial. If we have the 5x plus 3 example and the 5x minus 3 example, again, the 5x, the first term, in the binomial is the same. The second term in the binomial is also the second term in the binomial is 3 and 3 here, but remember, they're opposites of each other. One is positive, one is negative. So again, your values here, one is positive, one is negative, but your first term is the same. Again, when you have that being the case, your middle terms will cancel out. All right, so this is called the difference of two squares. All right, and it says when we have a binomial in the form of a squared minus b squared, that is called the difference of two squares. We can factor this out as a plus b times a minus b. All right, here we go. If we were to take a look at number 7, to start off, we're going to subtract 64 from both sides. And we would end up with 49k squared minus 64. That's going to equal to 0. They want us to solve this, so in the end, we're going to figure out what k is equal to. But before we get to that part, let's take a look here at what we just learned, and we understand that with the difference. Here, we can express it as a plus b times a minus b if we can square a and square b. Let's take a look. All right, can the a term be squared? All right, what times itself gives us 49? 7. So I'm going to say 7k. All right, and then what number times itself gives us 64? I would say 8 and 8. So let's try 7 minus 8. All right, times, and that's 7k, times 7k plus 8. All right, when we work this out, we're going to end up with 49k squared plus 56k minus 56k minus 64. These cancel out, so we're left with 49k squared minus 64, which is what we started off with. So we know that we're correct by writing 7k minus 8 times 7k plus 8 equals 0. Here we're going to solve. We're going to start off by subtracting 8 here with the positive constant to give us 7k equals negative 8. We divide both sides by 7, and we end up with one of the solutions being negative 8 sevenths. All right, as we continue on, we're going to add 8 to both sides for this one, and we end up with 7k is equal to 8. We then divide both sides by 7 for an answer of 8/7. Well, here we understand that for our solutions, we must write them in increasing order. So it's going to be negative 8/7 first and 8/7 second. All right, so number 7, the answer is for k. K is equal to negative 8/7, and k is equal to 8/7. Does that solution look interesting to you? Maybe one is positive, the other is negative. Interesting. All right, let's take a look at number 8. For number 8, it's the same process. We're going to see if we can find a number times itself to give us 121, which is 11 and p. So 11p and 11p. And then for 100, we know we can use 10 and 10. So 11p minus 10 and 11p plus 10. It's going to be equal to 0. All right, 11p times 11p is 121p squared. 11p times 10 is 110p. So we have again minus 110p plus 110p, and then negative 10 times 10 is negative 100. These middle terms cancel out, and we're left with negative 121p minus 100. So we know we're good. I did this just to make sure we were correct. So now we can just solve these two expressions, remembering that one is going to be positive, the other is going to be negative. So for the first one, 11p minus 10 equals 0. We add 10 to both sides, and we end up with 11p is equal to 10. You divide both sides by 11 for one answer of 10/11. All right, and then we're going to solve the other piece. All right, and that piece is 11p plus 10 equals 0. So that's the one we just did there. And now we're going to subtract 10 from both sides. And we end up with 11p is equal to negative 10. We divide by 11, and we see that we have, for our solution for number 8, we have negative 10/11 and 10/11 for our solutions. What are we noticing there? One is positive, one is negative. So the solutions for the difference of two squares is going to be opposite. The answers are opposite. Positive 10/11 and negative 10/11.